It's a perfect December night in Florida. The high that day was 86, the overnight low, 68. It's the night of December 6, 1972.
At this time, entering the final phases of the countdown, various elements of the team reporting into Test Supervisor Bill Schick with their go, no-go for launch.
Saturn V, AS-512, with Command and Service Module Serial 114, America, and Lunar Module Serial 12, Challenger, on top. Inside, the last crew to fly to the moon in the 20th century.
The Vice President in the firing room at the Launch Control Center, observing the final minutes of the countdown, and he'll watch the launch from here. The countdown has proceeded smoothly, picking up at 11:53 a.m. this morning. Our weather continues to look good as we aim toward a 9:53 p.m. Eastern Standard Time launch. Now T-minus 7 minutes 37 seconds and counting. This is Kennedy Launch Control.
Apollo 17 is the culmination of a golden age of science spending and technology advancement. In many ways, it is the last ember of the optimism of the 1960s. This celebrated era, the capstone of a generation, is coming to an end. 17 is aiming for a 9:53 p.m. liftoff. There are an estimated 700,000 spectators for this ultimate manned launch of the mighty 33-story Saturn V, which tonight sparkles like a jewel rampant against the night sky, center stage and draped in spotlights. Frosty ice and wisps of vapor cling to its sides. 1,000 miles away in Houston, Flight Director Gene Kranz, watching the countdown, is growing uneasy as the Mocher suffers a series of power glitches and display system failures. Flight controllers are getting antsy and consider relocating to emergency backup consoles.
I want you to select your launch phase displays now, and I don't want any changing except those displays that are mandatory and required by each console position. We've had some problems in the VSN.
Despite the frustrations of the evening, the countdown inches ever closer to T0.
A cover aboard the cue ball. This is the cue ball system on top of the launch escape system. Will be pulled off just shortly before launch. First stage propellant tanks have been pressurized. Now past the 1 minute mark, and we are going on internal power. Now all systems to internal power. We'll be looking for the engine start sequence at the 8.9 second mark in the countdown. The engines will build up to a thrust of 7.6 million pounds. T-minus 30 seconds. We have a cutoff. We have a cutoff at T-minus 30 seconds. We're standing by at T-minus 30 second mark. We'll bring word to you just as soon as we get it. We have a cutoff at T-minus 30 seconds. T-minus 30 seconds and holding. This is Kennedy Launch Control.
For the first time in Apollo's history, the terminal countdown is brought to a screeching halt because of a physical issue. Nobody breathes as the rocket just sits there, at a state of T-minus 30 seconds, earth-rattling quantities of chemical energy stored within its walls. Apollo 17 is making history, but not in the way anyone expected or hoped. The 10th scheduled lunar landing, what would have been Apollo 20, was cancelled shortly after Apollo 11 in 1969. 19 and 18 would follow suit the next year, after the incident that crippled Apollo 13 and threatened to send the entire program spiraling into the ash bin of history. This meant that after Apollo 13's return, just 4 more lunar surface missions were left in the capstone program that held the attention of the world during the Summer of Love and championed the dreams of a presidency tragically cut short. But Kennedy's dream has now turned into Lyndon Johnson's liability. The Vietnam War, the Great Society, and Apollo all contribute to growing American debt. And the 1968 election proves that Americans are ready for a change. By 1971, first-termer Richard Nixon has implemented a sweeping series of austerity measures, effectively ending the US dollar's convertibility to gold and proposing severe cutbacks to government spending. NASA's Apollo program, backed into a corner, has to fend off several attempts to gut it completely. Given the situation, they are quite lucky Apollo 17 is flying at all. But with the mission itself secured, 2 major outstanding questions remained. Who and where to? Shortly after the mission of Apollo 15, in the summer of 1971, NASA would have their answer to the first question, but it wasn't nearly as easy as it had been on prior flights. Knowing full well that this was to be the final mission, there are special considerations to be made. Normally, the Apollo 14 backup crew would automatically be in line to fly the 3rd mission later as the prime crew. This would mean that 2-time spaceflight veteran Eugene Andrew Cernan flies as the commander, with Ronald Elwyn Evans flying as command module pilot and Joe Henry Angle flying as lunar module pilot. Like Apollos 13, 14, 15, and 16, the crew would consist of a veteran commander and 2 rookies. 17's crew would be an all-Navy crew, like Apollo 12. Apollo 12's command module pilot, Richard Gordon, served as the backup commander of Apollo 15. This would, under normal circumstances, place him in line to command Apollo 18, which by now has been canceled for a long time. However, Gordon is vying for command of 17 because he has an ace up his sleeve: Harrison Schmitt. Schmitt is a member of Astronaut Group 4, 6 professional scientists chosen in June of 1965. All classes before them had been test pilots and engineers. Group 4 was the first to be chosen on the basis of research and academic experience. Schmitt is a geologist by trade, having a Bachelor of Science in the subject from Caltech and a doctorate from Harvard. He has been with NASA now for nearly 7 years, playing a key role in landing site selection and astronaut geology training, but he himself has never flown into space. However, as the first Apollo flights were leaving Earth, Schmitt was busy becoming proficient in lunar module systems. By the time he serves as the backup lunar module pilot of Apollo 15, he is fully qualified to fly to the moon, and perhaps uniquely qualified to explore it. The community of scientists working with NASA on Apollo, especially the geologists, feel so strongly about sending an actual geologist to the moon before the end of the manned landings that they impose significant upward pressure to fly Schmitt on 17. This would involve breaching long-standing NASA protocol, but as Gene Kranz would come to observe, with Apollo 17, the usual protocol did not apply. Things begin to look even worse for Captain Cernan when, on the 23rd of January 1971, he crashes his Bell 47 helicopter into the Indian River. He survives relatively unscathed, but his future is cast into doubt. The cause of the crash is unanimously labeled pilot error.
And he had been distracted by something or other. He flew that helicopter right into the water, nosed over, blades all over the place, tail rotor blades all over the place.
Despite Cernan's 2 prior flights into space, including one to the moon on Apollo 10, His 1971 helicopter accident does not inspire confidence in mission planners, who question his ability to command such an incredible responsibility as a lunar landing. There are some individuals, such as Apollo spacecraft program manager and former astronaut Jim McDivitt, who are hell-bent against Cernan's selection for command of 17. But McDivitt's strong protestations do not sway Deke Slayton, Director of Flight Crew Operations, or Christopher C. Kraft, Deputy Director of the Manned Spacecraft Center, both of whom are willing to overlook Cernan's incident. Deliberations continue until late that summer. With only 3 seats to fill, and so many vying to fill them, whatever the outcome, the decision promises to be one that leaves a scar in the personal relationships of all involved. A bitter pill to swallow for the bittersweet conclusion of manned lunar exploration. The crew of Apollo 17 is announced in August 1971. Commander, Gene Cernan. Command Module Pilot, Ron Evans. Lunar Module Pilot, Jack Schmitt. Cernan's chosen LMP, Joe Engle, is bumped off of his crew and replaced instead with Jack Schmitt from Gordon's crew. Cernan, Evans, and Schmitt. They would be the ones to fly the final lunar mission. Shortly thereafter, Jim McDivitt resigns from NASA, pivoting into the private sector. Joe Engle, one of NASA's most gifted pilots, has forever lost his chance to walk on the moon. Admirably, however, his response is perhaps the most noble of anyone who ended up on the losing end of the Apollo 17 crew decision. His support for the Apollo 17 flight remains unwavering. He dedicates himself to helping Jack Schmitt improve his LMP skills for Apollo's final flight. The backup crew for Apollo 17 would also be highly unlike previous NASA protocol. Dave Scott, Al Worden, and Jim Irwin, the Apollo 15 crew, would serve as 17's backups. However, when the stamp scandal throws their reputation into question, they are quickly and quietly replaced with Apollo 16 astronauts, John Young and Charlie Duke, and Apollo 14 command module pilot, Stu Roosa. The history of Apollo 17's prime and backup crew selection reflects the chaotic dynamism of NASA's manned spaceflight program at the time, as America makes a hard turn away from human solar system exploration and towards a new policy of developing low Earth orbit experience and infrastructure. But now that the question of crew has been settled, a new one emerges. Where on the moon to send them? All of the high-priority landing sites are given consideration. NASA has long wanted to land a mission inside of Copernicus crater, near the central peaks, but Apollo 12 samples may have already provided an age for this impact, and 3 missions, 12, 14, and 15, had all landed in the vicinity of Mare Imbrium. They could try for the northeastern quadrant of the near side, aiming for highlands near Mare Crisium, but this region of the moon was being explored already by the Soviet Union, which at this time was establishing a track record of successful robotic sample return missions. There was always Tycho crater, but even after 5 lunar landings, few believed the terrain there was navigable. It was simply too rough. There was also always the lunar far side, but that was simply too far and required too much special hardware to support. It was a risk that no one at NASA, other than perhaps Jack Schmitt, wanted to take.
But the scientific objectives are, one, to understand the history of the moon as it relates to the history of our Earth in particular and to the solar system in general, of which our Earth is part of. By relating that history to the Earth, we have a chance, and we suspected this before we ever explored the moon. We now know it that it is specifically true, that in the moon we have a window into the very early history of a planet in the near-Earth part of the solar system. That is a history which is almost totally obscured to us on Earth. The history from 3.3 billion years ago back to the beginnings of the Earth, say 4.6 billion years ago, is practically obscured completely on the Earth. On the Moon, that's where lunar history starts, and that's why it's exciting to Earth scientists who have for years been trying to find out what happened to the Earth in that very early time.
That narrowed it down to 2 craters and a valley: Gassendi, Alphonsus, and Taurus Littrow. All 3 sites are several hundred kilometers away from Mare Imbrium. Imbrium-related material seems to permeate the near side, and NASA wants to find a spot untainted by its pervasive ejecta. The goals for Apollo 17 are somewhat of an anachronism. NASA wants to simultaneously find the oldest highland material they can, as well as the youngest volcanic material they can. Material of volcanic origin has taken a center stage since the first 3 lunar landings. Apollo 16 struck out into the central highlands, only to prove to be a terrible disappointment. Despite being a complete operational success, it was nonetheless a strategic failure. The Cayley Formation was not a volcanic plain. It was never established that John and Charlie were able to sample the Descartes Formation, and if Stone Mountain was volcanic, it was nonetheless completely covered with ejecta from South Ray Crater. Apollo 16 was a revolutionary moment for the scientists on the ground. They realized only then that they had been overly reliant on terrestrial analogs, and had to throw away most of what they thought they knew, as the Moon does not share a common surface history with the endogenic Earth. Apollo 16 suggested that there are very few, if any, volcanically constructed mountains on the Moon. The only shame, of course, is that the moment of realization came so late in the program. Too late, in fact, for any of the flights to benefit from it. Apollo 17's landing site was selected 2 months before Apollo 16 left the ground.
Site selection in all the missions has been a fairly long and drawn-out process. It entails utilizing, or the utilization by NASA of a number of scientific advisory groups and the inputs of many individuals across the country, scientists primarily. The Taurus Littrow site in the northeastern part of the Moon at the edge of one of the large lunar basins called Cernan was selected primarily as having 2 major features that would allow us to hopefully complete, as near as that is possible to do, this first phase of lunar exploration. This makes it appropriate, as I said, because it gives the last mission the role of filling in the first and last chapters of a lunar history book that Apollo has the capability of writing.
The Taurus Littrow Valley is located on the eastern rim of the Sea of Serenity. Although Serenitatis was not flooded by lava until well after the formation of the Imbrium Basin to its west, it nonetheless seems to show signs of having formed beforehand, implying it was flooded not all at once, but in phases. There is a variety of albedos, suggesting the presence of both younger and older frozen lavas alike. The deciding factor would be observations made by astronaut Alfred Worden, who on Apollo 15, as he orbited above the crater Littrow, spotted dark halos in a valley in the Taurus Mountains, with dark streaks across said mountains' flanks, suggesting the presence of fire fountains, a type of volcanic vent defined by a continuous spray of magma, forming a persistent fountain of molten material shooting out above the surface. In February 1972, Apollo 17 was forever married to this valley called Taurus Littrow, assigned the objective of finding evidence of young volcanics on the lunar surface in a region formed, by ancient events. Cernan and Schmidt are to characterize the so-called massifs. A massif is a section of hills or mountains that is generally considered separate and contained from the terrain around it. In the evolution of the crust, a massif tends to retain its internal structure while being displaced as a whole. It is believed that these lunar mountains are crustal blocks that were thrust upward almost instantaneously a long time ago during the impact that formed the basin that would become the Sea of Serenity. It is hoped that Cernan and Schmidt can sample some of the youngest material ever encountered on the Moon on the valley floor, and then sample some of the oldest at the base of the massifs. Cutting across the floor of the small valley is a massive fault line, part of an extensive series of wrinkle ridges that transect the area. It cuts right through a crater named Lara by the crew, making it perhaps the youngest deformational feature in the valley. The higher section to the west was pushed eastwards, and along a large line the lunar crust appears to have buckled, forming what is called a lobate scarp. In some places, the scarp produces a difference in elevation as great as 80 meters. Cernan and Schmidt, equipped with their lunar rover, will charge the scarp head-on, climbing it and sampling the elevated material beyond.
We have a bust of Apollo, of the god of Apollo, on our patch. He represents not just Apollo, the Apollo program, but we feel that he represents, in the figure that he gives us on our patch, mankind himself. Represents knowledge, represents wisdom. And Apollo is looking out into the future. He's not looking behind, and he's not simply looking at the moon, someplace that mankind has been, and in a sense has a goal that mankind has accomplished, but he's looking on beyond the moon and into the future.
Gene Cernan and Jack Schmidt both have a profound sense of adventure and recognize the opportunity afforded to them. Both lobby mission planners and management to extend their surface stay time by any means necessary, even if it means cutting into abort propellant and science equipment. However, they are met with a stiff upper lip. There is so much riding on this last lunar flight that few want to push the risk further than is necessary. Many just want to get this mission over with as soon as possible and see the crew return home alive. NASA never grew fully comfortable with the fact that so much in the Apollo flight profile rests on single potential points of failure. With all they have achieved in such a short time, many fear their luck will one day run out. While Cernan and Schmidt will spend some 75 hours on the lunar surface, Ron Evans will make a variety of orbital observations in the Command and Service Module, now armed with a variety of new instruments not yet flown to the moon before, including a far ultraviolet spectrometer, an infrared scan radiometer, and the novel Lunar Sounder, a powerful surface radar that will ping the lunar crust, helping to establish an absolute lunar topographic profile that promises to penetrate the surface by 1.5 kilometers, and when correlated with the infrared scanning radiometer and orbital photography, will aid in locating surface rock fields, structural differences, possible volcanic activity, and fissures where gas may be emitting. In order to make room for these new instruments, Apollo 17 will not carry the sub-satellite that 15 and 16 deployed. The far UV spectrometer will attempt to detect and measure trace gases around the moon, such as hydrogen, carbon, nitrogen, krypton, and xenon, mapping their density and scale height in the process. Because of both Apollo 17's chosen landing area on the moon, as well as the time chosen to go, December 1972, the launch window for this manned lunar mission happens to open for the first time in Apollo's history at night. This unprecedented night launch of the Saturn V will provide a unique viewing experience never before seen of the mighty moon rocket, and serves as a uniquely appropriate send-off for the ultimate moonshot.
This Apollo Saturn launch control, we're holding at the 30-second mark. This was an automatic cutoff by the terminal sequencer. As mentioned, this sequencer initiates various actions. Each action must take place and must be completed before the next one can be initiated. If anything does not get completed in time, there will be an automatic cutoff. This cutoff was automatic, done by the sequencer. We're standing by now to check just what the problem was. Now T-minus 30 seconds and holding. This is Kennedy Launch Control.
We're now back on the pad, and as the mission countdown clock holds at T-minus 30 seconds, everyone is watching and waiting, trying to find out what exactly went wrong and caused the computer to stop the launch. Was it an issue with the flight hardware? Was it perhaps even sabotage? The tail end of 1972 comes on the heels of an international terrorism scare. A mass shooting at the Munich Olympics is still fresh in many people's minds. But it quickly narrows down to a defective diode on a circuit card in the terminal countdown sequencer, a ground-side computer that governs the largely automatic pre-launch functions during the final count of an Apollo flight. It failed to issue a command to initiate oxidizer tank pressurization in the third stage of the Saturn V rocket. The launch team actually noticed this and manually pressurized the tank. However, this manual pressurization did not provide the required feedback to the terminal sequencer. Without necessary confirmation, it automatically terminated the count at 30 seconds. The result of this one hang-up would be a more than 2-hour hold, as the launch team scrambles to work around the problem. Meanwhile, the crew is sitting on what is essentially a skyscraper-sized silo of high explosive. Apollo 17 begins to slip into its 4-hour launch window. Finally, at 12:25 a.m. on December 7th, the clock, now holding at T-minus 8 minutes, once again starts counting.
Roger, TC, understand challengers, go for launch. We thank you for the hardware, the help, and the prayers, and everything else that goes into making a good mission. We're going to do our best, and we're also going to have a ball.
We'll stand by for a final go from Norm Carlson, the launch vehicle test conductor. He's given a go. The launch operations manager now switching over to the Astrocom circuit. This is the circuit that the astronauts, the launch operations manager, and the spacecraft communicator will remain on. They have this private circuit to keep extraneous talk off of their circuit. They are checking in. They are checking in now on the Astrocom circuit, indicating that they are go. It's expected that given proper weather conditions, people will be observing this flight from as much as 500 miles away. This includes a large portion of the southeastern United States, the northern tip of Cuba, and the Bahama Islands. Now approaching the 2-minute mark. T-minus 2 minutes and counting, and the countdown continues to move along smoothly. Now in the terminal countdown portion. The automatic sequencer has stopped the replenishing of the liquid oxygen and the liquid hydrogen. We're standing by now to begin pressurization of the fuel tanks. The second stage fuel tank pressurized, third stage fuel tank pressurized. The countdown continuing to move along smoothly. T-minus 90 seconds. T-minus 90 seconds. Countdown continuing smoothly. S4B propellants pressurized. The indication now using the workaround showing the S4B propellants have been pressurized. Now looking at the liquid hydrogen tanks as they become pressurized. LH2 aboard the second stage pressurized. All propellants now aboard the second stage. Pressurize as we approach the 1 minute mark in the countdown. Mark T-minus 1 minute and counting. Now in the final minute of the countdown. At T-minus 45 seconds, Gene Cernan will make the final guidance alignment. This is the Mark T-minus 45, and Gene Cernan made that final guidance alignment. That's the last action taken by the crew aboard the space vehicle. Now approaching the half-minute mark. T-minus 33, T-minus 30 seconds, and continuing on now. Continuing on at the T-minus 26-second mark, T-minus 25. We'll get a final guidance release at the T-minus 17-second mark. T-minus 17, final guidance release. We'll expect engine ignition at 8.9 seconds. 10, 9, 8, 7, ignition sequence started. All engines are started. We have ignition, 2, 1, 0. We have a liftoff. We have a liftoff, and it's lighting up the area. It's just like daylight here at Kennedy Space Center as the Saturn V is moving off the pad. It has now cleared the tower. Roger, Gina, looking great. Thrust good on all 5 engines.
Okay, babe, it's looking good here. Roll is complete. We are pitching.
This is Mission Control, Gene Cernan reporting the launch vehicle maneuvering to the proper attitude. Everything looking good at this point.
17 is go.
Roger, 17, you go.
First stage looks good. Altitude 1.1 miles.
Okay, 1 minute, 68 degrees. Okay. Everything looks great over here. Okay. Okay. Stand by for max, coming through max 2. We'll be at 68 degrees.
Booster says we look good. We're on 2.5 miles.
Roger, 1 Bravo, we're going 1 minute.
Roger, Gene, you're looking great. Right on the line.
Everybody says looking great. Right on the line. We're now 1 mile down range. Launch vehicle 4.2 miles high.
Yeah, this thing shakes like the sun. Yeah, that's max Q. Wait till we get out of max Q. Stay down there, Q meter. Yeah.
Coming up on maximum dynamic pressure at this point.
Stand by for mode 1 Charlie, 17.
1 Charlie.
Mark, mode 1 Charlie.
The flight dynamics officer says we look good on all sources, right on the trajectory.
Roger, 17, you're go.
Hey, read that full couple of these.
Flight Director Gene Kranz taking a status for staging. We say we look good for staging.
Roger, we'll go here. You get your verb 82. Nope. Stand by for report. Okay, that's verb 82. Nope. Hit board cut off.
Roger, headway.
Okay, number 1
engine shutting down on time as planned.
Okay, here's 20. Where's the station? Okay, it's 19. Now at 41. 41, okay. 3.5 Gs.
Crew will experience maximum G forces of about 4 Gs at shutdown.
5 seconds. Gs. 4 Gs.
Coming up on the first stage shutdown.
Hold on. Look at that son of a bitch. Man. Jesus Christ.
And we've had shutdown on time on the first stage.
I guess we got all 5.
Roger, looking here, look good.
Okay, stand by up there.
Sure felt like it.
Stand by, hold it. I think we saw them all from here.
Roger, Jack, and the thrust is going, all 5 of them, they're running good.
Okay, 3 minutes inward go.
Yes, Roger, 17.
Dude, this is smooth. Okay, that's the tower switches on my baby. Go. Okay, 13. There's okay, we do have skirt step. 19. 15. 17. 18. Watch it, Jack. 19, there goes.
Power, your mode 2.
Roger, mode 2. Okay, manager, that's your straight command. Okay,
CMC is go, you're going right down the pike, 17.
Okay, Bob, I do confirm guidance. And ELS 7 regular.
Apollo 17 enters low Earth orbit 712 seconds after launch, when its single J2 third stage engine shuts down. Still enshrouded in the shadow of the Earth, the crew are rapidly approaching the first sunrise of their mission. There is a fine mist that fogs the windows of their command module, the typical contamination and residue experienced on many Apollo flights. But otherwise, Apollo 17 begins its journey in perfect condition. Those who are a part of the booster and spacecraft teams would be quick to point out that the issue experienced during the countdown was in fact a ground support equipment malfunction and not a flight hardware one.
This is Apollo Control at 24 minutes. Apollo 17 now in an orbit about 90 miles by 93 miles. And we'll be reacquiring Apollo 17 through the Knorr tracking station at a ground elapsed time of about 52 minutes 20 seconds, roughly 27 minutes from now.
Only spurious master alarms plague the crew as they make their first circle of the Earth, and then their second, as they prime their guidance systems and prepare their vehicle for the critical translunar injection burn that will give Apollo 17 the kinetic energy it needs to reach the moon some 85 hours from now.
Guys, I've got the word you wanted to hear. You are go for TLI. You're go for the moon.
Okay, Robert, understand. America and Challenger with their S4B are go for TLI.
That's affirmative.
You're a sweet talker.
And we're coming up now on 2 minutes until ignition. This burn again will be a 5-minute, 51-second maneuver.
One light on, we have ignition.
And very faintly, we copy the crew reporting S4B ignition. That's confirmed by the telemetry. The booster reports the thrust looks good on the S4B.
Roger, Gene. We're going around the room. Look go here. You're looking real good, Gene. Right down the line.
Cut off at 5-2. You read the biscuit? And it was an auto cutoff on time.
Understand, a guided cutoff on time. Looking great.
And I'm watching the tank pressures are venting. The tanks are venting.
Understand, tanks are venting.
Okay, I hope you got all that. It was a beautiful burn right through sunrise. Did you get the numbers?
Yeah, we copied your VI and your EMS numbers, and we've got a number for you. The maneuver start time will be at 3 plus 33 plus 27. 17, Houston, you have a go for T&D.
Okay, a go for T&D. Separation, Houston. Hey, check the, whoever it is. Okay. And check the other ones off. Okay, I'm going to start the, God, look at the junk. Okay, there's 15 seconds. Pitch her up.
The shock incurred by the pyrotechnic separation of the command and service module from the third stage breaks loose a flurry of ice and paint, which quickly swarms around the spacecraft like a blizzard.
Houston, we're right in the middle of a snowstorm.
Roger, and we like Comedy Delta.
Hey, look at that berth. That's going to be bright as all get up. And there goes one of the slop panels.
Roger, bet you never saw the slaw panels on the simulator.
No, but we've got the booster, and is she pretty? Challenger's just sitting in her nest.
Roger. Gene, while you're watching that, I just thought you'd be interested. We talked to some of our friends down at the Cape who watched the launch, and they said you were glow all the way until you faded into it. You couldn't tell you from a star. They saw staging, and they could just see you as a star way off in the distance until you faded out. Not a cloud in the way at all.
Okay, on my mark. S4B limb step. 3, 2, 1, mark it. Okay, we got it. Oh, man, did we? There she comes. Yeah, Lem came with us. Hey, Jack came in the Hasselblad. I think we're pulling in the right direction. Ooh, what a beauty. What a beauty. Yeah, the Earth. And Bob, we had almost a completely weather-free pass over Africa and Madagascar. And the scenery, both aesthetically and geologically, was something like I've never seen before, for sure.
Apollo 17, now configured for translunar coast, enters into a 3-day period of quiet preparation as the crew and spacecraft traverses the Big Black, the 384,000-kilometer distance of cislunar space. As they look upon their receding home planet, the unique lighting conditions afforded to them by the circumstance of their westerly nearside landing site makes 17's view of the Earth the best of all the manned flights that have ever traveled to the moon. A view that will become popularly known as the Blue Marble.
Bob, I know we're not the first to discover this, but we'd like to confirm from the crew of America that the world is round.
Roger, that's a good data point.
You mentioned something in Earth orbit that kind of intrigued me. You mentioned seeing the rainbow, and we were trying to figure out how you saw a rainbow up there, and you were in orbit already at that time. Do you remember that?
Well, we were speaking of the appearance of the sunrise.
Okay,
having a banded color appearance that varied as you approach sunrise.
This is Apollo Control at 6 hours. As Jack Schmidt gives the description of the Earth, Apollo 17 is 22,868 nautical miles from Earth, velocity 12,520 feet per second.
Stay tuned for the next installment on the Earth. I'll try to get out of this suit.
Okay, just take it easy, Jack, and we'll be listening.
Man, I've never taken it so easy in my life. I'll tell you, Bob. I couldn't have believed this would be an experience like it is now. Yeah, every time you turn around, there's something else to see and wonder what's causing it. Whether it's a particle zipping across the window or one zipping across the cabin or spring mechanics there in the zero-G. There's always something going on.
Roger.
Well, Jack, you're turning a very trained weather observer besides being a geologist.
Well, I'm enjoying it immensely, Tom, as you may have gathered.
Right.
It's a very interesting place to watch, I'll tell you.
Absolutely superb.
How are things on the home front, TP?
Gino, things couldn't be better.
Well, you might pass on all the good words from us.
Oh, will do. I plan to drop by and bum a cup of coffee tomorrow.
I'd love to invite you up here for supper.
Wish I could join you. I could make another couple remarks, but it'd be X-rated, so I shouldn't.
Okay, I'll accept that. You notice I haven't yet.
I'm very well pleased, Gino. Your language is superb.
A short time ago, the booster systems engineer, Frank Van Rensselaer, reported that after the final apps burn in the S4B third stage, which is targeting the stage to impact on the moon, he reported that the S4B stage was tumbling intentionally after that burn. And as he gathered up all his documents and packed his briefcase, on the flight director loop, he said, I've enjoyed working with you on the Apollo program. And flight director in training, Neil Hutchinson, replied, it's been nice riding with you. As Van Rensselaer finished his job for the last time, he packed his launch vehicle documents and left the room. Booster systems console was vacant for the final time in Apollo.
One minor problem faced by the crew is their water chlorination. Apollo crews produce water for cooling and consumption via their command and service module's fuel cells. Water intended for human consumption is first mildly chlorinated. After a treatment period of roughly 20 minutes, a second injection of sodium dihydrogen phosphate neutralizes the water. Afterwards, it's drinkable. 6 of the 13 chlorine ampules used on Apollo 17 have minor leaks. A very minor issue on a so far quite unproblematic flight. Flight Day 2 is shortened as a result of the launch delay that extended Flight Day 1, and Jack Schmidt provides regular weather reports as Apollo 17 travels out towards the moon.
Okay, I said you can look right down at the Cape area. That's the Cape that we know in Florida. And a little disheartening because the last time I was up here looking back from this angle, they were moving another Saturn V for another moon trip out on the pad already. But I guess they're working pretty feverishly out there on B.
Bobby, I always wish that you had a poet on board one of these missions so we could describe the things that we're seeing and looking at and feeling in terms that might transmit at least a part of that feeling to everybody in the world. Unfortunately, that's not the case. But he certainly couldn't look at that fragile blue globe and not think about the ancient sails of life that are crossing its path and wonder ahead to the present, to the modern sails of life that are represented by the men that developed out of that life that are sitting there next to you and you're around the country in all sorts of different guises and working towards the same end, and that is to put that life farther into the universe. I certainly hope that someday, not too distant future, the guy can fly and can express these things.
Bob, how do you read 17?
17, read you 5 by.
That's the strangest sounding Bob I ever heard.
He's taking a short break.
On flight day 3, the crew perform their mid-course correction burn with the service propulsion system and enter the LEM. When they remove the docking probe and drogue assembly from the tunnel, they discover that several docking latches did not behave as intended. However, manually exercising the latches seemed to clear up the issue, and everything in the LEM was otherwise in pristine, perfect condition.
Meanwhile, here in the control center, one of the docking collar capture latches is here in the control center being examined by flight controllers on trying to sort out why some of the latches apparently did not fully engage during the docking operation.
One of the experiments Apollo 17 flies is the ALFMED experiment, or Apollo Light Flash Moving Emulsion Detector. The ALFMED covers the front and sides of the wearer's head and will provide data on time, strength, and path of high-energy atomic particles penetrating the emulsion plates. This data will be correlated with verbal reports on flash observations during the tests. As on previous flights, all 3 crew members report seeing regular flashing with closed and shielded eyes once their pupils acclimate to the darkness, although Gene Cernan's initial, more dramatic reports are eventually chalked up to the phosphine effect. However, cosmic ray-related flashes are present for the 17 crew, and they corroborate the experience of prior Apollo flights.
Yeah, Houston, 17, thanks to a little South Carolina boy we had up here last time, we've got some Brits up here, and they're really not too bad. Got a little butter on them, and a little bit dry. Of course, could add a little more water to them, and it'd be a little bit better, but not bad at all.
Can't believe I'm hearing that from a real Yankee.
Of course, Kansas is not actually a Yankee. Let me tell you, that does not apply to the little old farm boy from Chicago. As you students of American history may recall, Kansas caused a lot of the problem we had with those 2 people. And Grit is causing the rest of it.
Apollo 17 disappears behind the far side of the moon, gunning for the LOI burn that will slow it down and place it into lunar orbit.
This is Apollo Control at 88 hours 43 minutes into the mission of Apollo 17. We have had loss of signal as Apollo 17 coasted behind the moon on the start of the first lunar orbit. Assuming a successful burn, the spacecraft should come out from behind the moon at 89:16:29 ground elapsed time.
Hello, America. How do you read Houston? Over.
America, Houston, this is America. You can breathe easier. America has arrived on station for the challenge ahead.
All of Apollo has been leading to this. With 17 successfully entered into lunar orbit, American exploration of the moon in the 20th century has entered into its final hours. Every second possible, the crew will be doing what they can to absorb the knowledge they stand to gain from seeing and studying this ancient satellite. As the seconds tick away, so too does an epic chapter of space exploration.
One is it was a tremendous national accomplishment in a very difficult time. And secondly, there were 450,000 people almost that made it all happen. The astronauts were the tip of the spear, but that spear was held by an awful lot of people. I mean, there was something happening all the time that made it special, but you said it, being there is the essential ingredient. You can talk about it continuously and forever, and until people actually experience it themselves, it won't be complete. And that's the way it was for me. I talked with my colleagues who had been there and had thought about it for a long time as a scientist as well as a pilot and astronaut. And being there was just something very different. Out in space, and to begin to think even further than I had before of what our endeavors on the moon were going to mean to understanding that Earth, its history, and the history of life.
So much now rides on the shoulders of the crew and systems of the spacecraft. This is it. Apollo 17's orbital science instruments come to life as it makes the most of its precious few days in lunar orbit. However, also during this time, the crew must make a series of burns to refine their lunar orbit and place them in a condition to land on the surface tomorrow. Some 4 hours after entering lunar orbit, Apollo 17 lights its service propulsion system engine again for DOI, trimming its 315 by 97 kilometer initial orbit into a closer, more refined 109 by 27. This first DOI burn is not as precise as on prior lunar flights, and that's by design. Tomorrow, just prior to lunar landing, Cernan and Schmidt will undock the LEM and conduct a DOI-2 maneuver using their RCS jets, which historically have always enjoyed a surplus of propellant. Purposefully splitting the DOI maneuver into 2 burns and using the lunar module RCS for DOI-2 saves fuel in both the primary landing engine in the LEM, the DIPS, as well as the service propulsion system of the command and service module. It is just one more procedural improvement that makes Apollo 17 perhaps the greatest, most efficient lunar mission ever flown by humans. They lean heavily now on the raw experience gained from 5 prior landings. They stand on the shoulders of giants. December 11th, 1972. Landing Day. Cernan and Schmidt wave goodbye to their command module pilot, Ron Evans, and batten down the hatches of the LEM in preparation for undocking. Apollo 17 will begin the first of 3 7-hour moonwalks shortly after landing, with no rest period between the landing itself and EVA-1. Apollo 16 tried to accomplish this but was unable due to a CSM engine problem that caused a 6-hour delay just prior to the landing itself. Today, however, all signs are shaping up, and the crew proceeds undaunted by any major issues.
Hey, if I don't find my scissors here one of these days, they might be back behind there. I don't know. Hey, Bob, just ignore everything he said. We'll leave him a pair of our scissors, and he's just worried about being hungry. Hey, I just saw a flash on the lunar surface.
Oh, yeah?
It was just right out there north of Grimaldi.
Challenger Houston, you have a go for undocking and SEP.
Roger, understand, and go for undocking and SEP.
Hey, sound real good, loud and clear.
Okay, America. We show you inside of 20 minutes, and you have a go for certain.
Houston, America. Roger, we'll do our best.
Challenger Houston, your go for DOI 2.
Thank you, Gordo. We're go here for DOI 2. Ryan, listen, this ridge you're coming on over, just stick your hand out the hatch and grab a rock. Gordo, this is spectacular. It is absolutely spectacular looking at that command module America down there coming across the surface. We're just tracking them at about a 30-degree dive angle. God, we've got Family Mountain, we've got Course of Massif, we can see the Scarp, we can see the Light Mantle, I've got the Great Cross, Camelot, Sherlock. Believe it or not, Houston, they're all there.
Challenger Houston, your go for PDI.
Oh, thank you, Gordy. We are go up here for PDI, and there's the final trim at 4. Ignition, Houston. Attitude looks good. Engine override is on, master arm is off. We got a decent quantity light on at ignition, just prior to ignition. GTC tank's good. RCS is good at 15 seconds. Oh, boy. Mags and vanes are closed. Okay, we have engine thrust at commanded thrust, full scale high.
Roger.
Man, that looks good. Vector weight building up, looking good. Attitudes are good. We got the Earth right out the front window. 30, Gordo, we're out of 74K. 73. You're allowed 2 quick looks out the window, one now and one when we pitch over. I can't see a thing except the Earth, that's what I'm telling you to look at. Okay, Gordo, I got Nansen, I've got Lara, and I've got the Scarp.
5 miles to landing.
We're level with the top of the Massif now.
Challenger Houston, we'd like you to cycle the PQGS switch off and then back on.
Okay, it's off, and it's back on. Quantity light is out.
Roger, that should be good now.
We should start dropping H-dot here a little bit. Mags and vanes are together, and we're north, has us north of track. There it is, proceeded. And there it is, Houston, there's Camelot. Wide on target. I see it. We got them all. 42 degrees, 37 degrees, to 5,500. 38 degrees.
Challenger, your go for landing.
3,000 feet. 53 degrees. Okay, I've got Balfe, I've got Poppy, I've got the triangle. That's 2,500 feet, 52 degrees. Approaching 1,000 feet, 57 degrees. Okay, you're through 1,000. I'm taking radar altitude and pings altitude degree. You're through 800 feet. H-dot's a little high. Yeah, I don't need the numbers anymore. Okay, you're 31 feet per second going down through 500. 25 feet per second through 400. That's a little high, Gino. Okay. 300 feet. 15 feet per second. Little high. H-dot's a little high. Okay, I've got P66. Okay. Okay, 9 feet per second down at 200. Going down at 5. Going down at 5. Going down at 10. Cut the H-dot. Your fuel's good. 110 feet. Stand by for some dust. Little forward, Gene. Little forward a little. 90 feet. Little forward velocity. 80 feet. Going down at 3. Getting a little dust. You're at 60 feet. Going down about 2. Very little dust. Very little dust. Stand by for touchdown. Stand by. Going down at 2. 10 feet. Contact. Stop push. Engine stop. Engine arm. Proceed. Command override off. Boat control ahead. Hold. Pings auto. Okay, Houston, the Challenger has landed.
Roger, Challenger, that's super.
Boy, you bet it is, Gordo. Boy, you said shut down. I shut down and we dropped, didn't we? Yes, sir. But we is here. Man, is we here. How's that look? Pressures look great. Houston, you can tell America that Challenger is at Taurus Littrow. Beautiful. And Jack, are we going to have some nice boulders in this area? Okay, the old camera's off. Okay.
The dust is gone. The vibration is gone. The noise is gone. Nobody's talking. And all of a sudden you realize for what could have been 10 seconds or 10 minutes, I don't know, that you are now seeing what has never been seen with human eyes before. You are now where no human beings have ever been in the history of mankind, ever before, where reality is almost like a dream.
2:54 p.m., December 11th, 1972. Apollo 17 has successfully landed in Taurus Littrow on the surface of the moon. There is little time to relax, and even less time to celebrate. Gene and Jack must safe the LEM systems and prepare it for the surface phase, get some food, and then begin the first EVA.
Oh, man, look at that rock out there. Absolutely incredible. Absolutely incredible. I think I can see the rim of Camelot.
Roger.
Epic moment of my life. Where'd you land? You never let me look outside at all. Hey, you can see the boulder tracks. God, look at that propellant. We could have gone all around and looked around. We should have hovered around a little bit. Gone look at the scarf. No, thank you. I like it right where we are. Okay, Gordy, we're hanging in for your go. It better be a go. The RCS hasn't changed. Ascent water hasn't changed. The batteries haven't changed. Oh my golly, only we have changed. You know, you can't see it in the Camelot, Jack. That rim is Camelot out in front of us. Yeah,
Challenger, you'll be glad to hear you're stay for T1.
We are stay for T1. Okay, you can get all I told you about Route 22 now 46.
There is some confusion as to exactly where in the valley they have landed, since from the surface level, they cannot see the large craters that would otherwise serve as the predominant landmarks. On this first moonwalk, the bulk of their time will be spent installing their nuclear-powered ALSEP scientific instrumentation package, which, like the SimBay in the Command and Service module, incorporates several new experiments not flown to the moon on prior Apollo flights.
Okay, coming open. You ready? You reading the checklist? Auto. You ready? Wait a minute. Okay. Open then auto at 3-5. Okay, go ahead. Okay, here it comes. I can see daylight through it. Okay, it's coming down. Okay, I'll start my watch.
Okay, we verify and we're counting.
Watch is started. Hey, something just flew out. It's open now. Guys, look at those trajectories. But just enough air in here. Okay, it's open, babe. Okay, it is open. When you're at 5 psi, it's we never did really train for this in the right way. Yeah, we did. Well, the next thing it says that Gene gets out. I don't see that. Houston, Commander is on the porch. Of Challenger.
Roger, we copy you, Commander, and your feed water pressure is looking much better now. You're probably getting coolant.
Okay, I got all my visors down. Jack, I wouldn't lower your go visor until after you get on the porch because it's plenty dark out here. Okay, tape recorder. I'm on my way. It's off. And Houston, as I step off at the surface at Taurus Littrow, we'd like to dedicate these first steps of Apollo 17 to all those who made it possible. Jack, I'm out here Oh my golly! Unbelievable! Unbelievable, but is it bright in the sun? Okay, we landed in a very shallow depression. That's why we've got a slight pitch up angle. The LEM looks beautiful. Oh, I'm on a porch. Who said this place was smooth? Oh boy. There's a lot of local depressions here. I didn't figure existed. Hey, who's been tracking up my lunar surface? Okay. Just walk around for 1 second. Hey man, put your visor down. And I'll be over there and you can fix my tool harness. I don't like that thing loose. I don't like it loose either. What are you doing over there? We're supposed to be working. I'm just going to give them a fix. All these little craters, Jack, have got glass in the bottom of them. Here's another one. Boy, your feet look like you just walked on them. Huh? Well, I tell you, Gene, I think next generation ought to accept this as a challenge. To see them lead footsteps like these someday. I may pull a Jim Irwin here. Wait a minute, watch out. Here she goes. Okay, on the plains of Taurus, Littrow. What a valley. I'd like to come down here through here with a T-38 sometime. That'll be the day. Dum-de-dum-dum-dum. Good thing we're well-coordinated human beings. Da-da-da-da.
Roger, and your exuberance is showing up on the BTUs. You're running a little high on those.
Exuberance? I've never been calmer in my life. Oh, man, hey, Jack, just stop. You owe yourself 30 seconds to look up over the South Pacific and look at the Earth. What? The Earth? Just look up there. Seen one Earth, you've seen them all. No, you haven't, babe. When you begin to believe that.
Deploying the rover now.
A geologist's paradise, if I ever saw one. Well, I'll tell you, it sure is easy to get dusty, but that's nothing new to anybody. Okay, babe, let me get... Whee! I think it's safe to say this surface was not formed yesterday. You'll find out... Hey, booze, it's alive.
Decliner phrase, it's a panoramic scene of beauty.
Oh, come on now, Bob. Oh, bury me not on a lone prairie where the coyotes howl. Okay, Jack. How about the flag right over here in this little mound? Which mound? Well, let me take a look over How about right up there on that little high point? Right up in here where I'm going. Yeah. Okay, let me come over and help you. How about right? How about right? Well, we'll find out how much reckless we got in a minute. Yeah. Hey, you're in the edge of a crater, though. That's no test. Well, that's all right. Move right over here near your tire tracks. Okay. Let me give it a few whacks. Oh, baloney. Okay. Watch your fingers. Well, that wasn't too bad. Want to make sure it stands up. Let's get pretty still. Well, how far we could drill. Don't know how far we could drill, but I think you hit something solid for that one. No, it was still going. Yeah, but did you ever see it vibrate like that? I've never put a flag up in the moon before. What? Pull that end. You're going to have to get it down to my level. Tall guys are all alike. How about getting it stretched out here? I will. I just can't start forward as fast as I'd like to. Hate to touch it, my hands are so dirty. Okay? Well, it's going to want to curl. Maybe it'll, take a couple this way and we'll take a couple that way. How's that? Oh, I ought to let me get over the other side. You got the rover in the background. Yeah, in the limb. It does wave when you do that.
We got a beautiful picture of you guys up down there.
Let me tell you, Bob, this flag is a beautiful picture. That's beautiful. This has got to be one of the most proud moments of my life, I guarantee you. I don't know how many of you are aware of this, but this flag has flown in the Moker since Apollo 11, and we very proudly deploy it on the moon in honor of all those people who have worked so hard to put us here and put every other crew here, and to make the country, United States and mankind, something different than it was.
Roger 17, and presuming to speak on behalf of some of those who work in the Moker, we thank you very much.
Well, we're off to see the wizard. Hey, do you need me, Gene? Nope. I'm going to go deploy an ALSEP. Have at it. First, I got to find an ALSEP site. Don't fall into Camelot. Oh, you won't believe it. You did it again. Oh, there goes a fender. Oh, shoot. Say, Bob, I'm moving down Sun. Well, I'll get that in a minute. I'm moving down Sun, and where we've walked, we stir up darker material, just slightly, but it's darker. The same old thing that most mature, the most regulars have. And I hate to say it, but I'm going to have to take some time and try. I'm going to try to get that fender back on.
Okay, was it the rear fender, Gino?
Yeah, I caught it with my hammer and it just popped right off. Jack, is the tape under my seat? Do you remember? Yes. I may need it. Okay. Let's say my hydroxide canister to middle. I'm in Max True Lane. Man, you're flopping around like a... How you doing? Oh, fine. It's just, it's work going out here. Yeah, I bet it is. Just take it easy. I am. I'm going to be a little bit behind you if I have to work on that fender anyway.
Yeah, you can walk a bit more slowly than you're walking.
Okay, more and more. Well, if it wasn't for that fender, I'd be ready to go. Makes me sort of mad.
17's ALSEP does not incorporate the traditional seismometers of prior stations. Instead, a compact series of simple geophones will be deployed in a triangular orientation, and then a series of explosive charges of varying size will be placed all across the valley during the 3 moonwalks. Once the astronauts leave, these charges will detonate, helping profile the subterranean structure of the Taurus Littrow Valley. Another novel experiment is a surface gravimeter that will provide insights into the moon's gravitational field, measuring such things as gravity waves. Gene Cernan will also periodically operate a portable traverse gravimeter to make precise gravity field measurements at various locations across the valley. There's also the Surface Electrical Properties Experiment, or SEP, that will measure how the upper layers of the lunar surface transmit electromagnetic energy. One experiment that has flown before, twice, is heat flow. On Apollo 15, the temperature probes meant to measure thermal conductivity below the surface were not placed far enough into the lunar soil due to fiberglass drill stems flexing and binding in the dirt. On Apollo 16, the experiment was broken when one of the astronauts nearly tripped over its wiring, ripping the wires clean off with no way to reconnect them. Apollo 17 is the last best hope for the heat flow experiment. Twice, this experiment has struck out. Will the third time finally be the charm?
Keep your eye on cables. Hey, Bob, has Ron been able to see the lab?
Stand by, I'll find out. Watch it, Jack.
I'm sorry. I knew it! I knew it would happen!
Here we go. Watch that cable. Cable! Watch the cable.
Cable number 1. You know, they're all fixedly, they'll break the whole world before they'll break the cable in time.
Man, don't hit that. Give me heart failure after all that drilling. First cable hook. Got it? You all right? Yep. I'll straighten it up in a minute. Once more I tempt the fate of the god of the cables.
Gene Cernan preparing to drill another hole. These cores will be brought back to Earth, and the neutron flux experiment will be placed in that hole.
Another novel experiment of note is a lunar neutron probe, which will measure the neutron flux in the top 2 meters of the regolith.
Ow. Arm start. That hurts. Oh, me oh my. I'm going to take a big drink of water here. We got 3 cores, we got the neutron flux down, and we got 2 heat probes, and an L step. Oh, Geoff, we are 30 minutes late.
Okay, and why don't we get you 2 guys together again now and break down the core and press on. And we got a little revision here to the EVA. I'll get with you in just a minute on as soon as I find out what it is.
Okay. Stay there. Okay, back. Thank you.
Gene and Jack press on, but they aren't working as fast as Mission Control would like. The realities of the moon quickly place a dampener on NASA's plans, as it becomes increasingly clear that the amount of time the pair will have to explore on EVA-1 is diminishing as the pair learn how to work in this novel environment. It was intended that the pair would hop on their rover and explore an area to their south, reaching as far as Emery Crater. Now, out of necessity, Geology Station 1 is cancelled, and a new point, Station 1A, also sometimes retroactively referred to as just Station 1, is improvised. It is much closer to the LEM, half of the initial planned distance, on the rim of a compound crater called Steno Apollo. There is simply not enough time to make the drive to Emery. Jack Schmidt, a geologist first and foremost, is deeply frustrated by this development.
Okay, I've got the transmitter. I'm heading west. Or east. Heading east. Sorry about that. I think we need to head south. Yeah, we got to go out here southeast. Boy, am I glad we didn't land out here. Whew. See this high point up here coming ahead? Yeah, that should give us our bearings, I hope. Bop, bop. I was strolling on the moon one day in the merry, merry month of December. No, May's the month. May, that's right. May is the year of the month. When much to my surprise, a pair of bunny eyes.
Sorry about that, guys, but today may be
okay,
December.
The battery covers. Okay, Bob.
Gene and Jack are unable to find Steno Crater. They landed further north of where they think they did. However, they stop at a small crater, later judged to be within 500 feet of Steno.
29 and a half. Yeah, it's 29 and a half minutes from now, but remember, they left this side a little bit late.
Jim, you better make it clear to Parker that we got to pull out.
Bob, you're going to want a core at this site?
Roger, we'd like to get #1 priority would be some block samples, including any dirt that was on the blocks, if there is such. And then the second priority is a rake soil sample. The third priority is a double core.
Okay. You want this charge deployed here?
That's affirmative, Jack, and
I'll deploy it now.
You can deploy it right now. That's good.
That's a 1-pound charge for the lunar seismic profiling experiment.
Beautiful. We'll give you the Taper of the Year award. And 17, a reminder to factories, you're thinking this is only a 30-minute stop and there's about 20 minutes remaining.
Yeah, 1.2 kilometers is a long way from the LEM. Look at the Challenger down there. Make you get a feel for how big this valley really is. I'd rather not. get the answer?
I tried to blow the dust off my camera.
We could get a...
About 4.4 billion years ago, the surface of the moon's outer crust must have looked not unlike the highland areas we see today, such as these on the far side of the moon. As the debris storms continued their declining ways, this cratered and pulverized outer crust was saturated by craters more than 50 kilometers in diameter. It is now composed largely of pulverized plagioclase feldspar, a silicate mineral, as you know, rich in calcium and aluminum, mixed with possibly 30% of mafic minerals. Both the mantle and the crust, however, have been greatly modified by later events and materials.
I think you have lost a fender. I keep getting rained on here. Oh, no. Look at our rooster. Look what's ahead of us there. Yeah, that's probably it. It probably didn't stay. I could see it in a shadow. Sure, look at it. Oh, boy. That's going to be terrible. That is really going to be bad.
Early in EVA-1, Gene had broken off the right rear fender with his geology hammer. During the first sleep period on the moon, astronauts and technicians in Houston would endeavor for a fix. Drawing inspiration from earlier Apollo jury-rigs, such as the duct tape, plastic bag, and sock adapter for the lithium hydroxide scrubbers on Apollo 13, they devise a new fender using lunar maps, duct tape, and clamps.
We're at 6 hours 36 minutes in this EVA.
Okay. Okay, verify SRC plus Z badge. What are those things going over? What is that, Jack? Hey, something just hit here. What blew? Hey, what is that? Oh, your antenna. It's that styrofoam off the high gain antenna package. On the LEM? No, the one you deployed. The rover high gain antenna. My God, it blew up. Yep. I thought we'd been hit by a. Look at that stuff just kept flying over the top of our head. I thought we were the closest witnesses to a lunar meteor impact. I thought you were kidding. No, I've never seen that before. Oh, I'm sorry. I thought that was a... No, you just, when you saw that stuff coming, I didn't see that at all. Holy smoly.
Roger 17, and John says that it blew up on his mission as well.
Oh, get up on that ladder and you get a whack at my legs best you can, and I'll kick my boots clean.
We've completed a shift handover in Mission Control. Flight Director Gene Kranz and his team of flight controllers replacing the Pete Frank team. Our spacecraft communicator on this shift is astronaut Joe Allen.
And I want to make the observation as a casual bystander, it was a real pleasure to watch your EVA unfold down here.
EVA-1, which had started an hour late, is terminated after 7 hours, 11 minutes, and 53 seconds. Already one of the longest moonwalks ever conducted. Cernan and Schmidt, exhausted from a day which has included undocking, DOI-2, landing, and EVA-1, settle down for their first sleep period on the lunar surface. They will spend the next 17 hours inside the LEM, resting and reviewing their plans for their first major exploration of the Taurus Littrow Valley on EVA-2.
Artie, Houston 17, how do you read, or Challenger, or whoever we are. I have calmed down, but be advised that our dinner is corn chowder. He went to Captain's Mast for eating that the other day. Who told me this was a flat landing site? It is flat. Crying out loud, what do you want? An airtight guarantee? Let's see, we got about 2 degrees left and about 5 degrees pitch up.
Near the conclusion of the period of large basin formation about 3.9 billion years ago, the moon's interior, through the accumulation of the heat of radioisotopic decay, gradually reached temperatures by which it could begin to influence the character of the surface regions. An electric dynamo probably came into existence, began to perpetuate itself, and produced a magnetic dipole field about 1/25 of that presently associated with the Earth. Although the dipole field has disappeared, the magnetic anomalies left in crustal rocks persist to the present.
December 12th. Cernan and Schmidt depressurized the cabin of their lander a second time, and once again walk outside into the valley of Taurus Littrow. Today is the largest and longest planned moonwalk in the entire Apollo program. The pair will board their rover and charge west, tacking back and forth across the face of the scarp and stopping at the foot of the South Massif, Geology Station 2.
Right at the beginning, while they were getting it ready, Cernan accidentally knocked off the right rear fender. Well, that gave them all sorts of problems the first day, that wheel kicking sticky black moon dust over everything. So Mission Control figured out a solution. The astronauts were advised to improvise a fender using maps like these and fastening them into place with clamps from a light inside to kind of form a fender like that. See? Well, it worked pretty well. So well, in fact, that the astronauts were later named honorary members of the Auto Body Association of America.
Okay. I'll hold it right there while I clamp it down. Now, that paper isn't going to come off, and the clamp's not going to come off, I'll say that. I don't know how much we're going to get out of the fender, but... Okay, let's fix, yeah. Can you fix that at all? Yep. That'll give us a little strengthening, stiffening. Yeah. Pretty tight. Yeah. A bit tighter for the road. I don't want to lose that. Man, that's tight. Now, let's see if I can get this one. Let me take a look before I get it too tight. Well, I'll tell you, that's going to help some. Yep. They do the trick. I can't see what's under this rail too well, but I know that clamp is on. I think that'll stay. I think it'll stay. I think that'll stop the rooster tail, because I think that'll stop a lot of it, Houston. That's swinging forward. Okay, let's go.
Okay, it's
maps are configured.
Sounds like a good attempt, men. We'll hope it works.
Does that look good to John, from what he did?
It looks exactly what he did, he says.
That tape will keep it. Okay, we're almost due south of the Alcep now. Just south of my Geophone 2 flag now. And I think we're coming up closer to the rim of Camelot. It's starting to look like a crater now. Okay, the surface is not changing in terms of the detail. The surface texture of the fine-grained regolith still has a raindrop pattern. The blocks still look very much like what we sampled yesterday around the limb. They're light-colored, apparently gabbros with zap pits, zap halos. Occasional craters show lighter-colored ejectives, both all the way down to, say, half a meter in size. Other craters that are just as blocky as those with bright halos have no brightness associated with them. Most of the brightest craters have a little central pit in the bottom, which is glass-lined. The pit is maybe a fifth of the diameter of the crater itself. It's a fairly standard thing for most of these pressure craters, is that little central pit.
On the way, the pair make 3 short sampling stops of no more than a few minutes each. These small, short traverse samples are simply to give a general impression of the valley floor as they travel some 7.5 kilometers away from their lander, the greatest radial distance any astronauts have ever traveled away from their spacecraft.
Oh man, it's Shevitz. Woo! Take a couple pictures looking at that. Okay, can you swing a little? Yep. Okay, I got him. That is a 600-meter crater. Hold it, Jack. Oh, watch it. Hold it, hold it. You can go around that one. Yes, you betcha. Woo! Let's slow the speed up a little bit. Get and wrinkle your toes now. Okay. Oh, I wouldn't worry, Gene. We're climbing, Jack, because I've been full bore most of the time, and all I can get out of this thing clicks, and when I decelerate, Gene decelerates in a hurry. Good vehicle you got here. Yeah, it takes a little getting used to, though. Yeah. Well, I tell you, if we can't recognize the change in that albedo when we get onto that white mantle, I'm going to be surprised. Woo! Oh, boy. That really gives me a strange feeling. Yeah, gives me a strange feeling, too. Those are not intentional. I understand. I'm not sure I got enough guts to make them intentional. That is a high mountain. Oh, gee, many Christmas. Listen, if the Earth goes behind it, we're changing station 2. Well, I'd say this is the last straw to the top. And is she working? Come on, baby. Bob, the boulder tracks are really just chains of small craters, for the most part.
Okay, copy that. That's interesting.
I don't think they can tilt the television camera high enough to see the top of the massif. Look at that. Wow. Look at that crater right there. Yep. That's where we're going to make station 2, right up here. Wait, straight ahead? Yep. Yeah, okay. Boy, you're looking right into Nansen. Yeah. We're right where we wanted to be for station 2. And it looks like a great place. Big blocks. It looks like quite a bit of variety from here. Different colors anyway. Grays and lighter colored tans. Can I change your oil?
Thank you, Gino. It looks much better.
How about any other service I can be? Okay.
Okay, and if I could remind you guys, you got a pan from up here before you leave the high uphill area here. There's no point in climbing up here twice, remember?
Yes, sir, Bob. How much time we got here now?
Stand by.
Jack Schmidt will often use the term gabbro to describe the rocks he is observing. Gabbros are incredibly similar to basalts, which much of the lunar missions up to now have primarily sampled. The difference lies in the size of the grains in the rock. Basalts cool quickly and have very fine-grained crystals. Gabbros cool more slowly, and their crystals are coarser. Chemically, however, the two are very similar. On Earth, gabbros are more often the product of deep formation, while basalt rocks form closer to the surface. However, as the experience of Apollo 16 has taught NASA, on the Moon that may not be the case. It is believed now that for possibly as much as 200 million years, the Moon was globally covered by a deep magma ocean, which may have lasted much longer than it should have, thanks to high thermal insulation and additional initial heating sources, such as tidal effects from the Earth. This magma ocean thus would have cooled and solidified more slowly, allowing for the development of large-grained rocks nearer to the surface, as well as the further concentration of elements such as titanium, allowing for the formation of specific minerals like ilmenite. Much of the basalts and gabbros on the Moon are relatively highly enriched with metal. The question quickly becomes where this metal in the rocks came from: meteoroids from outer space, or the lunar interior.
At 17, if you want to just take a minute, you might look up in the sky and notice that our camera is taking a beautiful picture of Mother Earth.
Isn't that pretty over there? Can you see the massif too?
We're coming down to look at the massif. Got a beautiful picture of the Pacific there. Ed finally found it. Now we see the massif.
Hey, Bob, how long have we been at this station?
Stand by. You've been here about 40 minutes right now. Can you believe it?
Is that right? Yeah, is there already, Jack? They wanted. I don't know how we used up all the time, but we did. I don't know where the hour went that it took to drive here. Maybe time's different in space. Adventures in space and time. We changed 2 hours and 40 minutes. I don't know whether that makes us older or not, but... Oh, my golly, look at that valley. That's beautiful. Isn't that something? Man, you talk about a mysterious-looking place. Oh, look at that. Oh, I'll tell you. that's the way to come downhill. Just don't stub your toe. Man, that's the way to come downhill. Hey, Gene. Yeah. Set up right there. Let's get that big clasp. There's a fracture right in there. I want to get the the clasp. Yeah. Yes, sir. Good eye. Good eye. Big white clasp. Good eye. In the gray matrix breccia. Good eye. Man, that's a prize. Let me get this over here so I can swing. And I think you can even get it. I get both sides. I'm going to get this big, yeah, I think I can get that. I'm going to try.
Beautiful station, guys. Just simply beautiful. Almost deserves a 1,000 code.
Man, I tell you, Falcon 109. I couldn't help that, Bob. It's just too beautiful.
As the magma ocean slowly crystallized, lighter minerals such as feldspar floated to the top, forming the original lunar surface. Iron and magnesium silicates like olivine and pyroxene sank, creating a molten layer of titanium-enriched magma sandwiched and squeezed between the two. Contraction of the crust due to cooling created intense pressure which gave rise to intense volcanism, spewing minerals such as ilmenite through the crust and out onto the lunar surface at weak points and basins carved out by massive impacts. The metals and minerals found within moon rocks provide the key to understanding the physical and chemical conditions under which those rocks formed.
There are your tracks. Hey, we crossed somebody's tracks.
I hope they look like yours.
Well, here's another set. Yeah, but this is where we went to that big crater and I came southeast in order to get around it, remember?
Issues with finding a level spot for the traverse gravimeter at Station 2 means that during their drive away from South Massif, the pair will have to stop for more than just a small sample. This slightly longer than planned stopping point becomes Station 2A, and the time it eats out of the overall EVA results in several activities being cut from Station 4 on the way back. The pair eventually arrive at Station 3 on the edge of the scarp.
Okay, and we're ready now for your pan, and don't forget your scoop.
I won't. Ah! You don't mind a little dirt here and there, do you, Jay?
No.
Oh, dadgummit. Well.
Hey, Gene, would you go over and help twinkle toes, please, Gene?
Really. I tell you, you fix that camera bracket so the bags stay on, and I'll be a lot better off.
Roger. And be advised that the switchboard here at MSC has been lit up by calls from the Houston Ballet Foundation requesting your services for next season.
I should hope so. How's that? About non-functional.
Okay.
And the left one is almost non-functional.
Okay.
Tacking northeast, the pair begin working their way back to the LEM, arriving at Station 4. One of the so-called Dark Halo craters spotted by Al Worden, this crater, nicknamed Shorty, would prove to be perhaps the most intriguing stop yet.
Okay. Oh, hey! Wait a minute. What? Where are the reflections? I've been through once. There is orange soil. Well, don't move it till I see it. It's all over. Orange! Don't move it till I see it. I've stirred it up with my feet. Hey, it is! I can see it from here. It's orange. Wait a minute, let me put my visor up. It's still orange. Sure it is. Crazy. Orange. I've got to dig a trench, Houston.
That's the volcanic mix.
Somebody unplugged silver.
Yeah, well, let's ask for an extension. Hey, Geoff, this is the last time for you to really go to bat for us, Geoff. We know you'll do it for us.
Send an extension for that L stuff.
There isn't enough time, Tony, to do it, no matter which way you want to do it. We need more time. We may have to slip. We have to slip 5 in a little bit.
They got to leave at a certain time regardless of what we got. Willing to give up all the light man.
Fantastic, sports fans. It's trench time. You can see this in your color television, I'll bet you. How can there be orange soil on the moon? Jack, that is really orange. It's been oxidized. Go around and get the lunar sounder over here. It looks just like an oxidized desert soil. That's exactly right. That orange is along a line, Gino, along the rim crest. Does it follow circumferential? Yeah. Man, if there ever was, I'm not going to say it, but if there ever was something that looked like a fumarole operation, this is it.
Orange and black glass spheres and fragments. The finest particles ever brought back from the moon at some 20 microns width. A 500th of a centimeter. They are absolutely, without a doubt, volcanic in origin. In this orange soil, Apollo 17 has struck gold. But they aren't nearly as young as the pre-landing hypotheses for the Taurus Littrow Valley might suggest. This titanium, iron, and zinc-rich glass is in fact several billion years old, not significantly different in chemical composition from standard mare basalts. The reason for its remarkably unique appearance, however, is that this material formed as a result of an explosive volcanic eruption, likely involving volatile gases, cooling rapidly into spherical glass beads. This was then buried under subsequent lava flows that would eventually form the valley floor. It was excavated back onto the surface fairly recently, exposed by the impact that created Shorty Crater, somewhere between 5 and 30 million years ago.
Okay, Bob, I'm going several meters around to the east and towards the south to get this pan.
Copy that.
And I'm going upslope. I'm on the rim, and I'm up. Oh, that ought to be a beautiful shot. I can see what my settings are.
Pressed for time, after spending longer at Station 4 than they had expected, the pair raced to Station 5, the rim of Camelot Crater, one of the biggest in the valley, at over half a kilometer wide. The pair discover there that the large boulders near the rim of Camelot are partially buried by the dark mantle material that makes up the valley floor, heavily indicating that it is not the original valley floor, but rather perhaps the topmost layer in a series of lava floods and massif avalanches that continually raised it over time. In fact, high estimates place the original valley floor some 1.4 kilometers below where it is today.
Here I am, folks, in the middle of the boulder field. Just minding my own business. Man, that's a hard moon. You know, I've worn the RTV off that hammer already. Yeah, I saw that. That's why I wore the RTV. That comes from 15 years as a trained hammer bearer. By golly, your geology training did come in handy. You learn where to hit rocks. Hippity hoppity, hippity hoppity, hippity hopping over hill and dale. Da 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 da. Hippity hopping along. Okay. My golly, this time goes fast.
At the conclusion of their second moonwalk, they had spent 7 hours and 36 minutes traversing more than 20 kilometers of rugged lunar terrain, making EVA-2 one of the most ambitious and successful spacewalks to ever be conducted.
Oh, I stand out here and I look at that flag and I look at the rover and I look at those teeth. What did we deserve to deserve being out here, huh?
I would look at my watch and I'd be on the moon, and you don't pay attention to what time it is back home because you're in a new time zone, you're in a new world out there, and it says 7 o'clock, and I'd look up at here. It's a unique place to be. I could look up at the Earth and see, hey, the sun is already set on Texas. It's going. Sun is setting on California right now. So my young daughter probably has done her homework and said her prayers and is going to bed, and I wonder if she's thinking of Daddy. She could watch and hear, and she knew what I was doing, but that was my only window into the reality of her life, so that I could, in my way, know what she was doing. That was my window into her life when she was a little 9-year-old girl, and her daddy was walking on the moon.
As Cernan and Schmidt enter their second surface rest period, Ron Evans continues working in lunar orbit. He will eventually record 10.5 hours of lunar sounder data, both with and without the conjunction of the surface electrical properties experiment, which can generate electromagnetic waves at the surface for the sounder to receive, measuring how those waves are altered by the lunar environment over nearly 100 kilometers of altitude from the ground to the CSM in its parking orbit. Minor problems are encountered with the extension and retraction of the sounder's antennas, but otherwise the experiment is working perfectly. He collects 100 hours of infrared scanning radiometer data and 80 hours of far ultraviolet spectral data. One of the interesting discoveries made by the ultraviolet spectrometer is a short-lived cloud that existed for some 4 hours after the descent and landing of Challenger, likely gases from its exhaust plume. The expected concentration of hydrogen in space around the moon was 10 times lower than predicted, seemingly suggesting that some mechanic on its surface is trapping stellar hydrogen and preventing its buildup.
In general, the data's been excellent. We're getting indications that the hydrogen atmosphere of the moon is much less than expected. In fact, I don't think we're detecting any, but rather setting a limit on the amount of hydrogen around the moon. Infrared scanning radiometer is performing beautifully. Indications are that subsolar point surface temperatures are higher than we've detected from our Earth-based observations before. We're seeing many thermal anomalies, particularly in the Procellarum area west of Copernicus. And we're seeing also a few unusual cold spots, which apparently are indicating areas of very fine soil with few or no blocks in and on the soil. The lunar sounder data is beautiful, and the power monitor signals we find correlate with the surface features. And the HF data indicates to us that we are detecting a variety of layers in the Mare areas.
One of the experiments flown within the command module is a container of 5 pocket mice called BioCore, or the Biological Cosmic Ray Experiment. This has the primary scientific objective of determining if heavy cosmic ray particles can actually injure the eye, brain, and other tissues. Radiation dosimeters were implanted underneath the scalp of each mouse, and the animals flew in a self-sufficient container on board Apollo 17 alongside the crew, staying in the command module for the duration of the flight. 4 of the 5 mice survived the trip. The survivors, as a necessary part of this experiment, were euthanized and had autopsies performed. The goal was to see if useful biological data could be obtained that would provide insights into how our bodies react to the penetrating radiation of outer space. No changes in brain, eye, or muscle tissues were observed that could be attributed to particle radiation. However, the nasal cavity tissue of all 4 surviving mice was in disarray, in the sense that the number of its constituent cells and the thickness of the mucous membrane layer varied from area to area, which is biologically abnormal. The 17 control animals on the ground that did not make the flight were entirely free from this change, indicating that it was indeed a function of the space environment, although it was never fully established whether the culprit was microgravity, radiation, or perhaps the canister itself in which the mice lived.
Okay, I'm on the porch. Yep, still there, Jack. Godspeed the crew of Apollo 17. Good.
Amen there, Gene, amen.
Okay, Bob, I'm on the pad. And it's about 4:30, a Wednesday afternoon, as I step out onto the plains of Taurus, Littrow. Beautiful valley. The first thing I'll do is I'll turn the TGE on and I'll give you a reading.
Okay, we're ready.
Okay, get the visor down, Gino. Get the visor down. Holy smoly. It'd be better to leave it up. Beautiful out here today, Bob. We can look to the east for a change, a little bit anyway.
Okay, copy that, Gene.
A higher sun angle.
160 hours, 52 minutes, 48 seconds. Cernan and Schmidt leave their lander for the 3rd and final moonwalk onto the lunar surface. Today they will be heading north, climbing up the face of the North Massif and swinging around a large boulder dubbed Turning Point Rock to the northeast, covering the opposite end of the valley to yesterday's trip.
Oh, no, Senex, that roll indicator north of Ding Dong says I'm rolled 10 degrees.
And the crew's on the way to Station 6 at the base of the North Massif. Station 7 is nearby to the east of Station 6. Station 6 is at the foot of what's believed to be a long boulder trail up the North Massif.
Rudolph would be?
No, if you're where we think you are, you're east of Rudolph quite a ways.
Yeah, I think you ought to know where we are by now, Bob.
Roger that.
That's Lewis and Clark.
After making 2 stops, they set up camp at Station 6.
Okay, we're parked on a heading of 107. You happy with that?
Roger.
You
Sounds
parked
great.
on a slope, too. There's no level spots to park here, though. You want me some help getting off? I gotta go uphill. I just about ended up down at the bottom of the hill. Oh, you got the brake on, I hope. You betcha. I don't know if I could lean uphill enough. I can't. Holy smoly. Why are we on a slope? You okay? Yeah, let me get this thing set again. I don't think you can get it. Are we on a slope?
These massive boulders are believed to have rolled down the slopes of the North Massif, and some of them may shadow patches of the lunar regolith permanently from the sun. Small zones of soil that may not have seen sunlight for billions of years.
Now, that foliation I mentioned does not go all the way through the rock. There are variations in texture. One zone was strongly foliated. There's another. It almost looks like a large inclusion of non-vesicular rock within the vesicular rock. And I never... You can't believe how tough it is getting around this river on this slope. I think I think we're probably pitch 20 and roll 20.
I can't believe we sampled the whole.
I can't believe we sampled the whole thing right on. Man, that's rough country in there, isn't it?
Well, you're looking across Henry.
Yeah.
Outstanding! Outstanding! This whole thing will come out here in a minute. Hey, I'm standing on a boulder track. How does that make you feel? That makes me feel like I'm coming over to do some sampling. Think I would have been if you were standing there before that boulder came by. I'd rather not think about it. Oh, and there's Challenger. Holy smoly. You know, Jack, when we finish with Station 8, we will have covered this whole valley from corner to corner. That was the idea. Yeah, but I didn't think we'd ever really quite get to that far corner. Not two, but this other one, and we're gonna make it. Oh, man. Yes, sir, we got a couple dented tires. Okay, my hands have had it.
Okay, good
Not
enough.
gonna get anything else out of me if I keep taking pictures.
And, Gene, what's a dented tire?
A dented tire is a little golf ball size or smaller indentation in the mesh. How does that sound to you? Doesn't hurt anything.
That sounds like a dented tire. That's how it sounds. Copy frame 3-1.
That's sort of like what it is. Okay. Yep. Remind me to dust my camera too, will you?
Okay.
Don't forget to dust your camera.
We'll keep track of that for you, Chief.
Okay.
The schedule today is more flexible than yesterday. There are not hard time limits set for each stop. The pair drive further to the east, sampling another boulder at what would become Station 7. They then begin dipping to the south, traveling horizontally and slightly downhill as they make for a crater named Bowen. They come to a stop at Station 8 at the base of the Sculptured Hills, a series of interlocking domes believed to be separate from the bordering massifs. The pair sample more exotic glasses, such as that found at Shorty Crater.
A reminder, 17, we'd like to have you leaving here in 30 minutes to make up some of the time we spent at Station 6 and 7 a little extra. And we'd also remind you that we'd like a rake soil sample here too. That may be the only way we try and pick up some stuff other than subfloor if that indeed has come down from the top of the Sculptured Hills.
Are you ready? Are you ready for this? I'm not sure I am, but go ahead. Go, roll! Look, I would roll on this slope, why don't you? 5-6 gravity that's missing. Hey, I bet you they would like, if I didn't step on it, trample out of the bottom of that thing. Too bad I don't have my skis. Dad, did you get a fan up here? No, I'll get one. Good, I forgot. I got interested in skiing. Woo! Can't keep my edges. A little hard to get a good hip rotation. The only way to go. Well, see, when I'm on level ground, I can skip. But this two-legged thing is great. Man, I can cover ground like a kangaroo.
Departing Station 8, they head south, rounding Cochise Crater and dipping southwest, finally traveling back towards their lunar module Challenger. They make their final stop at a fresh, sharp, young impact crater called Van Surg, that in many ways resembles Shorty Crater, visited the previous day.
The valley of Taurus Littrow, where the Apollo 17 landed, is a valley deeper than the Grand Canyon. The mountains on either side of the valley rise to thousands of feet in elevation. So you can see that it's a geologist's paradise in that you can see 3 dimensions. of at least the upper crust of the moon. The main thing is that the observations and the data collected on the Apollo missions, the samples that were collected, are really a gift that keeps on giving. There are thousands of students, thousands of professors, thousands of researchers around, not only around the United States, but around the world, who work on these samples and learn new things almost every day. As a matter of fact, just 2 years ago, NASA released some of the samples from our mission that have been kept frozen. And those are being worked on now. I have the privilege of working with the University of New Mexico team and also a team of some 90 scientists throughout the world who are working in various ways with new analytical technology on these samples. It was a very important decision made 50-some years ago in that we would not work on all the samples. We would freeze some of them so that new technology could be applied to their analysis. And that is being done today. But also we expect through the Artemis program, the new landing program on the moon, to have more samples. I think it's very important not to be too parsimonious with these samples that we have from Apollo, in that we certainly expect to have more samples coming back from the moon in the not too distant future.
Okay, and Jack, Houston, over.
Go ahead.
Okay, we've had a change of heart here again as usual, and we're going to drop station 10 now that we've heard you so much, and we're going to get a double core here. And we'd like to get some football-sized rocks while you're doing that, but double core here, and then we're going to leave here and go directly to the LEM.
You don't want to...
Here at Station 9, the pair run into dark, matrix-rich breccias. The rocks here were not excavated from below, but rather formed instantaneously, the result of traumatic fusion likely caused by the Van Surg impact event. As he had on the prior two EVAs, Jack Schmidt continues placing explosive packages for the seismic profiling experiment at various points along the traverse. Insufficient time remained for a visit to the crater Sherlock, so the pair drop off their final explosive charge and make for the LEM.
Are you through with this?
Roger. Roger, we're through with it.
Be kind, be kind. Well, I love it, and I'm sure it did a good job.
But we're not through with you, Gene, so don't throw yourself too far.
No, sir. I just don't want to hit old Challenger there. That was unkind. You get the javelin. That was unkind. Houston, before we close out our EVA, we understand that there are young people in Houston today who have been effectively touring our country, young people from countries all over the world, effectively touring our country, had the opportunity to watch the launch of Apollo 17, hopefully had an opportunity to meet some of our young people in our country, and we'd like to say, first of all, welcome, and we hope you enjoyed your stay. Second of all, I think probably one of the most significant things we can think about when we think about Apollo is that it has opened for us being the world, a challenge of the future. The door is now cracked, but the promise of that future lies in the young people, not just in America, but the young people all over the world, learning to live and learning to work together. In order to remind all the peoples of the world, in so many countries throughout the world, that this is what we all are striving for in the future, Jack has picked up a very significant rock, typical of what we have here in the valley of Taurus Littrow. It's a rock composed of many fragments of many sizes, in many shapes, probably from all parts of the moon, perhaps billions of years old. But a rock of all sizes and shapes, fragments of all sizes and shapes, and even colors that have grown together and become a cohesive rock, outlasting the nature of space, sort of living together in a very coherent, very peaceful manner. When we return this rock, or some of the others like it, to Houston, we'd like to share a piece of this rock with so many of the countries throughout the world. We hope that this will be a symbol of what our feelings are, what the feelings of the Apollo program are, and a symbol of mankind that we can live in peace and harmony in the future. A portion of a rock will be sent to a representative agency or museum in each of the countries represented by the young people in Houston today. And we hope that that rock and the students themselves will carry with them our good wishes, not only for the new year coming up, but also for themselves, their countries, and all mankind in the future. We'd like to uncover a plaque that has been on the leg of our spacecraft that we have climbed down many times over the last 3 days. And I'll read what that plaque says to you. First of all, it has a picture of the world, two pictures, one of the North America and one of South America. The other covers the other half of the world, including Africa, Asia, Europe, Australia, covers the North Pole and the South Pole. In between these two hemispheres, we have a pictorial view of the moon, a pictorial view of where all the Apollo landings have been made, so that when this plaque is seen again by others who come, they will know where it all started. The words are, "Here man completed his first exploration of the moon, December 1972 AD. May the spirit of peace in which we came be reflected in the lives of all mankind."
Gene and Jack, I've been in close touch with the White House, and the President has been following very closely your absolutely fascinating work up there. He'd like to wish you Godspeed as you return to Earth, and I'd like to personally second that. Congratulations. We'll see you in a few days. Over.
Thank you, Dr. Fletcher. We appreciate your comments, and we certainly appreciate those of the President. And whether it be civilian or military, I think Jack and I would both like to give our salute to America. And Dr. Fletcher, if I may, I'd like to remind everybody, I'm sure something they're aware, but this valley of history has seen mankind complete its first evolutionary steps into the universe, leaving the planet Earth and going forward into the universe. I think no more significant contribution has Apollo made to history. It's not often that you can foretell history, but I think we can in this case. And I think everybody ought to feel very proud of that fact. Bob, you might be getting TV the way the antenna's oriented right now.
Okay, I don't think. Yeah, we're getting TV there, Gino.
Oh, what a nice little machine. We're just two little sets of twinkle toes here. There's a lot that goes to getting this rover running out here that we don't have much to do with. Please. It's all yours. You got the You deserve it. A hammer thrower, you're a geologist, you ought to be able to throw it. You ready? Go ahead. You ready for this? Ready for this? Yeah. Don't hit the lem or the outstep. Look at that. Look at that. Look at that. Beautiful. Looked like it was going 1,000,000 miles, but it really didn't. Didn't it?
The astronauts receive the Lunar Neutron Probe experiment, and once Jack Schmitt ascends the ladder for the final time, Commander Cernan, right behind him, takes a moment to reflect on the greater Apollo effort and the mission they have conducted thus far.
This is Gene, and I'm on the surface. And as I take man's last step from the surface, back home for some time to come, but we believe not too long into the future, I'd like to just let what I believe history will record that America's challenge of today has forged man's destiny of tomorrow. And as we leave the moon and Taurus Littrow, we leave as we came, and God willing, as we shall return, with peace and in hope for all mankind. Godspeed, the crew of Apollo 17.
Roger, Gino. Thank you very much.
Bob, I am up on the ladder, and I'm going to be going through the hatch.
The pair jettison trash and other equipment not necessary for the return trip. After a 7-hour and 15-minute EVA-3, the two have completed their exploration of the Taurus-Littrow Valley. Across all 3 EVAs, they had spent a combined 22 hours and 4 minutes outside, 4.5 hours of which was spent driving their lunar rover, in which they covered nearly 36 kilometers, or some 22 miles over the lunar landscape. By the conclusion, the zippers and cuff joints of their spacesuits have considerably stiffened as they grow ever more clogged with moon dust.
Boy, everything is stiff. Everything is just full of dust. There's got to be a point where the dust just overtakes you and everything mechanical quits moving.
The pair will sleep one final time in their little house in a valley on the moon, and the next day, December 14th, they will fire the single Ascent rocket motor and attempt a rendezvous with Ron Evans and Command Module America.
Houston, from the old backup crew that followed you every step of the way. Super job on EVA, you guys.
Was that Charlie? I haven't heard your voice. Didn't sound, you know, all those good things you tell us about dust and all those other things, you know, you believe them all, just like everybody else does, but you just got to come out here and experience it for yourself to really be a believer.
And Challenger, we have a good word from the old program managers. Even though you guys were pretty piggy there on bringing rocks back, we're going to let you keep them all. You only busted the red line by 40 pounds.
For his part, Evans conducts 2 engine burns that trim his orbit in both altitude and inclination, placing him in the proper envelope for a rendezvous by Challenger.
Okay, whoa, there we go. We got ignition. About 87. Okay, number 2 is coming on. We're up to 90 on the Delta VC.
On Apollo 15, mechanical issues with the ground-commanded television assembly camera of the lunar rover prevented its pilot, Ed Fendel, from tracking the ascent stage during liftoff. On Apollo 16, He had begun tracking it too late, and it had shot out of frame. This will be his final chance to get it right, as he attempts to keep Challenger in frame during its takeoff, both panning up, zooming out, and then panning down. All of his commands are delayed by almost 1.5 seconds. He has to predict what will happen and send his commands to the camera beforehand, slewing it at the right time to capture the pitchover of the ascent stage. Inside the LEM, Jack Schmidt attempts to film the takeoff using the 16mm DAC, but a last-minute jam prevents him from doing so.
Take your final look at the valley of Taurus Littrow. Up from orbit. Camera's not going to run without me holding it. The average speed 20 seconds. Ah, shoot. Okay, let's get off. Forget the camera. 99, proceeded. 3, 2, 1. Ignition. Right away, Houston. Vector good. Ag side. Pitch over. Roger, you have good thrust. Okay, 30 seconds. 308 your number. Okay, coming through 1,500 feet, and H-dot looks good.
Roger, we've lost data right now, but we'd like aft Omni, please.
Awful on a static, Jack. We break lock? Yep. Why don't you get it on an Omni or something? Yeah, I got it on the Omni.
An issue threatens to plague ascent when Cernan and Schmidt are unable to talk to Houston. But working with each other, they overcome this period of blind comms and continue monitoring their burn, re-establishing voice contact just prior to entering lunar orbit.
See if we can get calm. I will. Well, those are the angles. How about an Omni? I've tried it. I've got, Houston in the Volare Challengers go coming up on 325 and 30K.
America, would you relay to Challenger to go aft Omni?
We are aft Omni.
Okay, they are an aft Omni right now.
Okay, America, tell Challenger we're reading them 5 by.
Several post-insertion maneuvers are required, but 2 hours later, the two spacecraft successfully initiate radar tracking of one another, and the terminal rendezvous begins.
Okay, Houston, we're reading you loud and clear. We're at 1 mile, and I just broke it to 30 feet per second. CPI was nominal.
Okay, Challenger, that's good news.
Ron, I'm going to stop it here, and you can do your maneuver. Okay? Okay, I'm station keeping on you.
Okay, I'll do my bird 49.
You seem okay, Jeff? Okay.
Okay, will do. Stand by. Just want a couple of pictures here.
Yeah, I'm going to get the radar out of the way, but I'm not going to, I'll lose him here as soon as his fifth funder gets out. I'm going to just station keep. Ron, your probe looks good. I can see it extended.
Okay, great.
The radar holds you, well, we don't hold you anymore.
Omni Delta in America.
America, we'd like Omni Delta, please.
Houston, America.
Omni Delta.
And that's the landing site down there. You pitched right through the landing site.
You did?
Yep.
Hey, good. You're,
don't hit that hand.
Yeah.
What a super flying machine.
Still looks kind of tinny to me.
Pad module looks just as good as the day they put it on the pad.
Hey, no, so does Challenger, my gosh. You're missing some of the pieces.
Now, what big piece we left behind?
Yeah, right. Okay, she's coming back around now.
Hey, give me a call when you start to retract.
Okay, will do.
Okay, I'm stable now.
Okay.
Looking good now.
Looking good, yeah. Yeah, that's what we needed.
Okay, she's looking good. Let's go to free. We'll go to retract 1.
Okay, mark it. I'm free.
Okay, retract. Here he comes.
Okay, it sounded good in here.
Yeah, it sounded good in here.
Okay, Houston, we're hard docked.
Okay, say it's Pyro. Logic is coming off.
Roger, understand. 2 gray.
Circuit breaker is open. 2 gray, that's a burn.
Following a perfectly nominal docking with no issues whatsoever, the crew, once again reunited, get busy with the task of transferring some 110.5 kilograms, nearly 244 pounds, of the moon from one spacecraft into another. They will jettison their ascent stage once it is closed and sealed, whereby Houston will remotely activate its engine and purposefully smash it back into the Taurus Littrow Valley that Gene and Jack had called their home for 3 days.
Okay.
Hey, here he comes, my God. How you doing? Beautiful. Good show. Oh, is it cool up there? It's hotter than down here. It's stuffy. Okay.
Over the next several hours, the explosive charges placed across the valley floor by Jack Schmidt will detonate, generating a strong seismic signal to help the geophones map beneath the lunar surface. 191 hours into their flight, the crew of Apollo 17 let go of the lunar module Challenger, its mission at an end.
I know there's not as many smiling faces down there as there are up here, but we're making up for the difference in numbers.
What was that? Ron, we'll drop Challenger right on the southwest seat for you for your birthday present.
Thank you, Gene. Okay, we copy that.
And Houston, I think the last few days have proved that they really did save the best till last. I need to get some maneuvering here, Gene. Okay.
Hey, you can probably tell by the comments, this is Jared. The gold team's been handed over to the able hands of Neil before things go too far. I'll be around watching for the rest of the flight, of course, but before things got too far, I wanted to pass my comments on to you guys that, boy, it's really been super. You guys have, between the performance of you guys and the performance of the hardware, it's been a piece of cake down here. I hope it's seen that same way up there. And we're really looking forward to finishing this thing up and getting you on back home.
Jerry, that spacecraft we were working with was undoubtedly the best vehicle along with America that I've ever flown.
Apollo 17 will continue to stay in lunar orbit for another day and a half, continuing to operate the orbital science experiments of the Simbay and making visual observations out of the command module's windows. During this time, the lunar rover's television camera limps along, making distorted, final broadcasts as it begins to overheat and its batteries die out.
The significance of Capcom Gordon Fullerton's comment to the crew a few minutes ago that the LCRU had crumped, as he put it, is that we're no longer able to get television from the lunar surface. The television picture comes back through the Lunar Communications Relay Unit. The Instrumentation and Communications Officer here has tried numerous times to command the TV on, and the commands are not getting through. So apparently the TV is no longer available to us.
For the first time in seemingly several days, we see the Earth.
Raj. Standing by for a weather report. Say, we got one question for Ron. We got large teams of engineers trying to locate the missing scissors, and we haven't asked you in a while whether you might have found them. It might save them a lot of effort down here.
Well, no, I haven't found them yet. And
the LSUB staff support room here in Mission Control reports that the last of 8 seismic charges left on the lunar surface by the Apollo 17 crew has detonated. These charges are a part of the lunar seismic profiling experiment. The seismic waves produced by the explosions provide information that scientists can use in interpreting the subsurface structure in the area of the landing site.
when you pine for the sunshine of a friendly game. For the holidays you can't beat home, sweet home.
Good morning, Robert. Good morning.
Good morning, Gino.
Hey, your choice of music's getting better down here. We're going to have to keep you there every morning.
234 hours into flight, Apollo 17 passes behind the lunar horizon one final time, having spent some 148 hours in the vicinity of the moon. Their 143-second SPS engine burn will impart a velocity change of nearly 1 kilometer per second and will place them on a 3-day journey back to Earth.
The television picture, as Apollo 17 comes around into acquisition of signal, we regain radio contact, should be a very spectacular view of the lunar surface. The spacecraft at the time we acquire should be at an altitude of about 291 miles above the lunar surface, moving out at more than 5,500 miles per hour. And it will be almost directly over the crater Tsiolkovsky, which is on the lunar far side, normally not visible from Earth. This will be the second time that we've had a chance to view the lunar far side via television from an Apollo mission. The first time occurred on Apollo 10.
Gordy, as we're maneuvering, I guess we've got one of the most spectacular views of the boat I've ever seen from a position like this. It's like just short of being 100% full. We can still see from Tsiolkovsky all the way across the moon. And it's just absolutely magnificent. And I'm afraid we're talking here that pictures just won't capture the real three-dimensional picture we're looking at. But uniquely with the binocs, I can still see the light mantle in the landing area.
You know, Houston and America and the world, this is a command module pilot of the Spaceship America, and I just feel quite honored and proud to have been a part of this Apollo program. The moon itself is a magnificent, well, I hate to use the word dynamic because it's really not dynamic, but it's a marvelous planet. It has all the wonderful opportunity for exploration. Man must explore. We will continue to explore, and I hope that someday we may all have the opportunity to see mankind enjoy the benefits of the exploration of the Apollo program.
11 days into their mission, on December 17th, Ron Evans prepares to make a deep space EVA of about an hour to retrieve massive film reels and data cassettes from the camera systems, lunar sounder, and spectrometers in the sim bay. The service module will not be recovered at the conclusion of the flight, so Evans has to retrieve this valuable data for stowage inside the command module. He is the third and final person to go outside in cislunar space.
Stay that way. We'll stay that way. Okay. Houston, we're standing by for your go.
Here I go.
Okay, Ron, here's a note. Okay, lock stem release valve is one on the side, push it down to yellow, right? Unlock, indicator release, white goes to yellow. White goes to yellow, okay. Gearbox selector unlatch. Gearbox selector to unlatch. Actuator handle unlatch. Actuator handle to unlatch. Unstow actuator handle. Okay, let's stow the old actuator handle. And the hatch is yours. Unlock it. Here we go. 1, 2, 3. I got a hold of it. And a bunch of trucks going out there. Oh, there goes the fan. That's different. Okay.
Those are felt tip pits. No scissors. Hey, there's the Earth right up ahead. Okay, Rod, you've got the crescent Earth. You've got to go for egress. Beautiful. And just take it slow. Okay, first of all, I got to get back in and get the old TV camera. Hey, this is great. Talk about being a spaceman. This is it. Oh, this is great, I'll tell you. The paint on here is just, it's a silver paint. And it's just little blisters on it, so you can kind of peel it off with your finger. Yeah, it rolled off the other way. Yeah, I can see the moon back behind me. Beautiful. The moon is down there to the right. Full moon. And off to the left, just outside the hatch down here, is the crescent Earth. Maybe I can get a picture of that, the Earth coming back in there. But the crescent Earth is not like a crescent moon. It's got kind of like horns, and the horns go all the way around, and it makes almost 3/4 of a circle. Okay, here's a piece of the thermal blanket from the Simtor jet. Hey, Houston. They were just kind of laying there underneath the EVA handle.
Roger, we see it. Confirmed.
Okay. Okay, here's the 10 cassette cover. And, there it goes.
Roger, we see it, Ron.
Okay. Let's see. Okay. Not a bad performance by my CMP, was it?
It was beautiful, and we had a beautiful television show. Really beautiful.
Houston, here's the crew of Apollo 17, Spaceship America.
Roger, Apollo 17. If you're ready for the questioning, I'll begin. Now that you are returning home from what may be the last lunar exploration of this century, what short-range and long-range plans do each of you have for the future?
Well, my short-range plans are certainly to enjoy Christmas with my family, think about the flight, get its data down on paper. My long-range plans are to turn around and look at the next flight, whatever that may be, and put my efforts and experience towards that flight and get to work on it. So many things, but I think probably the thing that, when I think about it, that'll stick with me most is the same thing that stuck with me over my last two missions. It's not so much being there, but it's getting a chance to get home and share what you've seen and what you've done with other people. Prior to leaving, and I guess I can certainly assume during the flight, we've carried many well wishes and carried many prayers aboard from people throughout the world. I personally believe that those prayers played no small part in any success that we were able to achieve on this flight. I ask those people, however, to continue their prayers, in particular for some of our friends and some of our comrades who are still in Southeast Asia, POWs, MIAs, who may not, although God willing, I hope they will, but who may not have the opportunity to get home and enjoy the Christmas that we're looking forward to. And with that, from Apollo 17, Spacecraft America, on December 18, 1972, we all wish you a very, very Merry Christmas and a happy holiday season. Godspeed and God bless you all.
Thank you, guys. That was a good show. We enjoyed every minute.
We start today's newscast out with this historical fact. Today marks the 69th anniversary of man's first flight in a heavier-than-air powered machine. Wilbur and Orville Wright of Dayton, Ohio, took 3 historic flights on the sand beaches at Kitty Hawk, North Carolina. The brothers will be honored today at a ceremony at a visitor center near the flying site. Now a look at the news. There's apparently been a serious hitch in the peace talks between the U.S. and North Vietnam. Dr. Henry Kissinger, in a curt news conference at the White House, has said that the North Vietnamese have reneged on earlier agreements and have brought the peace talks to a halt. Dr. Kissinger said the unresolved problems, which center around the number of peace supervisors and their placement, is not acceptable to the President, and Kissinger feels, and we quote, "We have not yet reached an agreement that the President considers just and fair."
These stalled peace talks between the United States and North Vietnam will result in Operation Linebacker 2, an intense B-52 campaign over Hanoi that will later be dubbed the Christmas bombings.
Former President Truman remains in serious condition at a Kansas City hospital. Doctors say the 88-year-old Truman is not responding to treatment.
Harry S. Truman, the 33rd president, will not recover and will pass away on December 26, 1972.
Houston, America.
Okay, CMP.
Hey, good.
This probably isn't too good a time to have an emergency. The reason I say that is we got a big Chinese feast going on here in the Moker.
You do?
Had some food brought in, and everybody's probably more interested in eating than the America right now, I must admit.
Uh-oh.
Apollo 17 continues falling back to Earth. Just a few hours before entry, the crew commences a slight mid-course correction burn with their RCS jets. So precise was the initial trans-Earth injection burn out of lunar orbit that a velocity change of just over half a meter per second is required. The precision and accuracy of which Apollo 17 has time and again been able to operate with is truly unparalleled, the result of continual advancements in hardware, procedures, training, and planning. A hair over 300 hours after launch, the crew jettisoned their service module and are now locked to their fateful encounter with Earth's atmosphere.
3, 2, 1, mark. We got it. Did we get it? That thing really bangs, doesn't it?
Altitude 1,781 miles, velocity 29,486 feet per second.
The floor of the Taurus Littrow Valley was eventually confirmed to be a lava flow. The seismic charges detonated revealed its thickness to be greater than a nautical mile. Prior to the flooding of the Serenitatis Basin, the massifs rose nearly 5.5 kilometers above the original valley floor, well below the reach of any impact craters in the valley. As the mission of Apollo 17 revealed, Taurus Littrow was indeed the site of intense volcanism, but not recently.
This is Apollo Control with the network controller. Dave Young will hang the final plaque in the Apollo series on the upper wall of the control room here. And this circuit, known up until now as Gemini Control, then Apollo Control, will reappear as Skylab Control. This is Apollo Control out at 3:05:25 ground elapsed time.
The scientific legacy and technological impact of Apollo has already been summarized on this channel in videos past. But what has not yet been acknowledged is the impact of Apollo on the human lives that made it happen. From the astronauts to the controllers, the leadership of NASA down to the groundskeepers of KSC, Mercury, Gemini, and Apollo was a 12-year span of incredible growth, bold action, and unparalleled expansion. A shared high moment in the lives of all involved, laced equally with the disappointment of failures, the tragedy of premature death, and the triumph of national achievement. It was, To quote Flight Director Jerry Griffin, "A little snippet of time when we left this planet and went elsewhere. A ride that few wanted to end, but knew couldn't last." Many would stay at NASA, continuing to write the history of American perseverance in space. Many, too, would leave, some by choice, others by necessity, melting back into normal lives, forever changed by their experience here, in this place, at this time. They would spend the rest of their lives grappling with an existential question. What does one do after the moon? As the strands and connections of our living memory with this era grow ever more tenuous, we can only hope that our generation one day becomes worthy of the sacrifice made by so many to make it possible. Apollo, forever the example towards which we continue to strive.
There's a storm across the valley, clouds are rolling in. The afternoon is heavy on your shoulders. There's a truck out on a 4-lane, a mile or more away. The whining of his wheels just makes it colder. He's an hour away from riding on your prayers up in the sky. 10 days on the road, barely gone. There's a fire softly burning, supper's on the stove. It's the light in your eyes that makes him warm. Hey, it's good to be back home again. Sometimes this old farm feels like a long-lost friend. Yes, and hey, it's good to be back home again. There's all the news to tell him. How'd you spend your time? What's the latest thing the neighbors say? And your mother called last Friday. Sunshine made her cry. You felt the baby move just yesterday. Hey, it's good to be back home again. Yes, it is. Sometimes this old farm feels like a long-lost friend. Yes, and hey, it's good to be back home again. Oh, the time that I can lay this tired old body down, feel your fingers feather soft on me. The kisses that I live for, the love that lights my way, the happiness of living with you brings me. It's the sweetest thing I know of, just spending time with you. It's the little things that make a house a home. Like a fire softly burning, supper on the stove. The light in your eyes, it makes me warm. Hey, it's good to be back home again. Sometimes this old farm feels like a long-lost friend. Yes, and hey, be back home again. Hey, it's good to be back home again, you know it is. Sometimes this old farm feels like a long lost friend. Hey, it's good to be back home again. I said, hey, it's good to be back home again.